Hello, I'm Mike Walker. Welcome to a demonstration of exploring the interop namespace and explaining why it's important to any SMIS implementation. In particular, we'll be looking at the SMIS 180 array. This demo is shown as a quick start guide for the interop namespace on my GitHub site for SMIS mocks, as identified in the video on installation and setup for running mock-ups of SMIS Webm servers. The interop namespace contains common elements for any Webm server. It contains profile definitions, accounts for who can access the server, roles they play, indications supported by the server, and indications supported by the servers. The Quick Start Guide is a 20-page document, and it highlights information that can be found in about 400 pages of SMIS spread across one SMIS book, the Common Profiles book, and 5 DMTF profile documents. In this script, we'll be working with pywbem 1.1.1 and version 080 of pywbem tools. We're going to be using the pywbem CLI. So let's begin. We will switch to my command prompt window. First, we'll go to our virtual environment for mocks, and we'll do that with a work on mocks command. And we're in the virtual environment. Now we'll be working with the mock server that supports that SMIS 1.8 array. We'll point out items, and we'll point out items that were introduced after 161. So we need to connect to the array mock. We'll do that with the pywbem command, which will drop us into pywbem command mode, interactive mode. So it's pywbem CLI, and the -o table means we want the default output to be in table format, and we're connecting to the array mock. All right, we've connected to the array mock. So the first thing we'll look at are instances of registered profile. Each defines a standard behavior supported by the Webm server. So let's look and see what registered profiles we have. And we'll do that with an instance enumerate command. And we see we have quite a few registered profiles. In fact, there are 18. Some are autonomous profiles. Some are component profiles. Those are profiles that support autonomous profiles. And one represents SMIS itself. And that's this one. It's saying it's SMIS 1.8.0. Now, you can tell which profiles are autonomous profiles because SMIS requires autonomous profiles to be advertised using SLP. So this is an autonomous profile. That's the array profile. And down here we have a server profile. That's advertised with SLP. And the Webm server profile. So there are actually three autonomous profiles, not just the array profile. Technically, the DMTF registered profile is also an autonomous profile, but in SMIS, the profile is treated like a component profile. Of these profiles, the Webm server profile and 3 of its component profiles, the IP interface, and the role-based authorization, and simple identity management were all introduced after SMIS 161. Now, to verify that all the profiles support SMIS 1.8, we'll issue the following shrub command. And I'll explain how shrub commands work with this as well. So first we're going to switch to output of in MOF format. We're asking for an instance shrub. Now a shrub is everything that is directly related to the object you're looking at, which is SIM registered profile. But in this case, we're asking that we restrict the associations we look at to SIM element conforms to profile. So we want to do this for the SMIS profile. And the SMIS profile is profile number 13. So we'll select that. And we get another long list. And what the shrub command shows, starting from the registered profile, SMIS 1.8, that is the conformance standard, and an element conforms to profile association to managed elements, and the managed elements happen to be registered profiles. And all of these profiles are all the other profiles other than SMIS that we saw in the enumeration of registered profiles. Now, SMIS uses something called the scoping methodology. This means autonomous profiles must have an element conforms to profile to their central instance. SMIS doesn't have a central instance, it's just, but we'll ignore that. That is, a central instance is a SIM class instance that is central to the implementation of the autonomous profile. So let's look at central instances, and we'll do this for each of our autonomous profiles. And we will do it with a shrub command. Again, in MOF we're asking for output in MOF format. We're doing an instance shrub on registered profile, restricting access to via SIM element conforms to profile. And this time we're looking to do this on our autonomous profiles. So the first autonomous profile is the array profile. So we're going to select 0. And here we see when the array profile is the conformance standard, there's an element conforms to profile to a managed element, which happens to be a computer system, and it's a system with this name. Now that means the central instance of the array profile is a computer system. There's also the element conforms to profile back to SMIS 1.8, which we saw earlier. Now, the next autonomous profile is a server profile, so we're going to repeat our command, and this time we're going to select, well, I think we are. This time we're going to select number 14. So when the registered profile, from the registered profile for server, as the conformance standard, the element conforms to profile goes to a managed element, which is a SIM object manager. And this is the name of the object manager. And of course, it also refers back to SMIS 1.8, but the point is The central instance of the SNIA server is, in fact, an object manager. And the last autonomous profile is the DMTF Webm server. And that's going to be item number 17. Then we have the Webm server as the root of the shrub. It is the conformance standard when an element conforms to profile to a managed element, which is a system. In this case, it's a system, but it's different than the array system. So this is a system that manages the management server itself. Now, and we see both the DMTF Webm server and the SNIA server have been implemented in this mockup. That means the interop requirements for both servers should be present. The DMTF server is new in SMI-S 1.8. The SNIA server was the profile or the interop namespace in the first 6 releases of SMI-S. So let's start by looking at what the Webm server calls for. And for this, we're going to do another instance shrub on registered profile. But this time, we're going to restrict this to reference profile. So we're looking for the things that are directly related to the registered profile following the reference profile association. Now, we're doing this for the Webm server, so we're asking for 17. And we see when the registered profile is a Webm server, you follow a referenced profile, and it takes you to a bunch of other profiles, and these are the component profiles of the Webm server. So we have the DMTF profile registration, IP interface profile, indications profile, job control profile, role-based authorization profile, and the simple identity management profile. So let's compare that to the SNIA server profile. So we're going to run the same request, but this time we're going to ask for the server profile, which we see up here is going to be 14. And we ask for 14. And we see a shorter list. When the registered profile is a server, you follow a reference profile to the component profiles, and they are the indications profile and profile registration. Now, I will point out this profile registration is different than the one that the Webm server requires. This profile registration is a SNIA augmentation of the DMTF profile registration. The SNIA profile registration augments the DMTF profile registration by adding a requirement for the element conforms to profile back to the SMI-S registered profile, and it also adds software information about what software supports the interop namespace. Since the mock server is claiming to support both the DMTF Webm server and the SNIA server, the SNIA augmentation also applies to the Webm server and vice versa. But SMI-S only requires one of the servers to be implemented. Now, the next thing we're going to look at are accounts and identities. Accounts and identities are managed by the simple identity profile. identity management profile, which is new, a new profile introduced by the Webm server profile, and it came in after 161. So first we're going to start by looking at accounts, and we'll do that with an instance enumerate. On SIM account, asking for a property list of name, user ID, user password, organization name, requested state, and enabled state. And we see we have two accounts, one for Jane and one for John, with their password. Jane is in an organization of storage systems, and John is in a client lib organization. And the requested state and enabled state are both enabled for both of them. So that brings up the question of what are these accounts related to. So we're going to do an instance shrub on SIM account to see what is directly related to an account. We're switching to MOF format like we usually do with the shrub command, and we're doing the shrub on SIM account. That's going to tell us all the things the account is related to, and we don't care which one we'll look at. We're going to look at number 1, which is selection 0, and we see the account for the first one is a part component for a SIM account on system, and the group component is in fact a system, and it is the server system. We also see that the account is a managed element that has a assigned identity to an identity, which is ident 0. So let's look at assigned identities and see what ident 0 is, as well as any others. So we enumerate instance of SIM identity, and we see ident 0 is Jane Doe, and there's a ident 1, which is John Doe. They correspond to the accounts that we pulled up. So let's now look and see what the identities are related to. And we'll do that with an instance shrub in MOF format on SIM identity. And we'll select 0 to see what Jane is related to. And she's related to quite a few. So from a SIM identity, in this case ident 0, there's the assigned identity association to the account, and we saw that going in the other direction a few minutes ago. There's also an antecedent role that plays an antecedent role to a concrete dependency to a role. So ident 0 is related to a role, and the role's name is admin. Finally, there's it plays an affected element role in a service effects element, and the affecting element is an account management service, and that's the name of the account management service. So we've introduced the concept of roles. Roles are defined by the role-based authorization profile. Another profile is new in SMI-S 1.7 and SMI-S 1.8. Now let's see what the interop namespace has for roles with the following command. We're going to instance enumerate sim role. And we see we have two roles. There's an admin role and a user role. Has a common name of administrator and user. Element name is storage administrator or storage user. And the role characteristics are static. That means they were predefined by the system. So the next question is, what is the role associated to? So we're going to do an instance shrub on role, again in moff format, and we'll pick just one of the roles to see what roles are related to, and we'll pick the admin, which is in keeping with the other things we've looked at. And we see, oops, well, there's quite a few here. Let's go through these. So we looked at the role admin, and it plays a dependent role in a concrete dependency to an antecedent, which is a SIM identity. So this is something we looked at before. It's the relationship between the role and the identity. There's also an owning collection element. So the role is an owned element in the owning collection association to the owning element, which is the system, the server. This is the server system we've seen before. And next, there's the role limited to target association. So the role is a defining role in the association, and it goes to the target elements. And the target elements are two systems. This is the array top-level system, and this is the server system. So it basically is saying the admin role applies to both the array system and the server system. Finally, there's a service effects element association. And again, the admin role is affected by the service effects element, and the affecting element is the role-based authorization service, and this is the name of the role-based authorization service. So that covers roles and identities. The next thing we're going to talk about are indications. Both the Webm server and the SNIA server profiles support the DMTF indications profile. An indication is an unsolicited message that is sent from the Webm server to any client that is listening for the indication. It is a SIM equivalent of an SNMP alert. The messages supported by a Webm server are defined by instances of SIM indication filter. Indication filters can be static, predefined by the Webm server, or dynamic, created by a user of the Webm server. In either case, we can see them all by enumerating instances of indication filter. So we are going to do that and see what indications are defined in our mock server. So we're going to do an instance enumerate on SIM indication filter, and we're asking for a property list of name, system name, individual subscription, and source namespaces. And we actually have a rather large list of indications defined in this server. we see there are 24, and I don't think they all fit on one screen, but I'll go up to the top here. They have a name, they have the system name. All these say individual subscriptions are supported, and the source namespaces are basically all the same. So in this list, there are 24 indication filters. That is, there are 24 different events that this Webm server may send to clients that are listening for the indications. In this list, a number of them are new since 161. They include change in pool managed space, change in pool total managed space, pool capacity, that's down here further, pool capacity condition has been cleared, that's this one. And finally, storage volume returned to normal. Storage volume returned to normal service. These are all new that weren't there in 161, that are in there now in 180. So next, let's look at what the indication filters are related to, and we'll do that with a shrub command. If I get down to my prompt here. So we're doing the shrub in MAW format again, and we're doing the instance shrub for indication filter to see what filters are related to. And we have to pick from one of these 24, so I'm going to pick number 4, which is for disk drive creation. So we have the indication filter for disk drive creation, and it plays a member role in a collection. So it's a member, you follow member of collection to a collection, and the collection is a filter collection, and it happens to be DDL, the DDL filter collection. DDL stands for disk drive light. And it also has a relationship to a service. It is the affected element in a service affects element association to the affecting element, which is the indication service. And this is the name of the indication service. Let's first look at the service. For readability, I'm going to do this with 2 commands because one command gets a table that's wider than the screen. So the first is enumerate instance of indication service, looking for name, delivery, retry attempts, delivery, retry interval, and filter creation enabled. And we see the name of the service is indication service. Delivery retry attempts are 3. That means 3 times they'll try to deliver the indication to the listeners. Delivery retry interval is 30, and the S up here in the header is telling us 30 is 30 seconds. And the filter creation is in fact enabled. Now, the second command, we're looking for other information that's in the service. And this time, we're repeating the name just so we know it's the same service. And we're looking for subscription removal action and subscription removal time, or time interval. And we get the indication service. The subscription removal action is ignore, and the time interval in seconds is 0. Now, let's look at filter collections. and see what they tell us. And we're going to do that with an instance enumerate on filter collection. And we have a number of filter collections. There's one for the array, there's one for block services, one for disk drive light, one for FC target ports, one for job control, one for the multiple computer system, and there's a static filter collection. Now, each of the indication filters can be related to a filter collection for profiles that support indications, or they may be related to a global indication filter. If the filter is related to a specific profile, then it is generated for that specific profile elements. If it is in a global filter collection, which we don't have here, it can be generated from multiple profiles. These filter collections are associated to registered profiles we see from the following commands. Command. So we're going to do an instance from and mouth format on filter collection and follow the association concrete dependency. And we're going to select item 2. And we see the filter collection for disk drive light is associated through concrete dependency to a registered profile, and the registered profile is in fact disk drive light. So the next thing we want to do is an instance shrub on the filter collection, but this time we're going to follow the member of collection. So we're doing the same instance shrub on filter collection, except we want to follow the member of collection association. And we're going to pick on disk drive light again. And we see that the disk drive light filter collection has members, and the members are indication filters, and they are disk drive creation, disk drive deletion, and disk drive status change. We also see the collection is a member of another collection, following member of collection the other way. You see it's a member of the filter collection, and we see that this collection is a collection of static filter collections. So the last topic we need to cover is Webm protocol management. We have the IP interface profile as a component profile of the Webm server profile. This profile is required if the Webm protocol management is supported. This can be determined by looking for an instance of SIM Webm service capabilities, Webm protocol service capabilities, that has a value of true in the listening port management supported property. So first thing we need to do is check and see if this condition is met. And we'll do that with an instance enumerate of Webm protocol service capabilities, looking for a property list of instance ID and the property listening port management supported to find out if it's true, and we see it is true. So Webm protocol management is in fact supported by this mock. Again, this is something new in 1.8. It wasn't there in 1.6.1 or earlier versions of SMIS. Now, the other thing I'd point out, we asked for Webm protocol service capabilities, but what we got was sim_SIM_XML capabilities. Now, the reason for that is sim_XML capabilities is a subclass of Webm protocol service capabilities. So that explains why we got a different answer from what we asked for. So next thing we want to do is see what else is in the capabilities, and we're going to have to do this in 3 requests, again, because one request won't fit on the width of the screen. So instance enumerate Webm protocol capabilities, asking for a property list of instance ID, authentication mechanisms supported, and max connections. And we see the authentication mechanism supported is unknown. The max connections is 1. So we'll run the second command. See what else we got. And this time we're asking for instance ID, requested state supported, and Webm protocol version supported. And the requested state supported are enabled, disabled, and reset. And the protocol version supported, it says 2.0.0, but it actually is any release in version 2. That's what that means. Finally, our last instance enumerate on the Webm protocol service capabilities is going to look for generic operations capabilities. And here we see something we haven't seen before. The generic operations capabilities is actually an embedded instance of the SIM generic operations capability structure. And we see that FQL is not supported. That's filter query language. And CQL, that's SIM query language support, is 0, meaning it's not supported. And then we see a bunch of operations supported, and these are SIM generic operations. And basically, this is telling us all SIM generic operations are in fact supported. So the next thing we're going to do is we're going to look at the protocol service. And we'll do that with another instance enumerate. Instance enumerate SIM protocol service, the property list of name, health state, max connections, and operational status. And we see the name of the protocol service is SIM XML protocol service. No surprise. Health state is okay, max connections is 1, and operational status is okay. Now let's see what the protocol service manages. And to do that, we're going to do an instance shrub on protocol service. So again, it's a shrub command, so we ask for it in MOF format. And we're doing this for the protocol service. And we have quite a few associations, so let's go through these. The protocol service is a managed element and element capabilities, and it goes to the SIM XML capabilities. So this saying the services capabilities are defined by the SIM XML capabilities. Then we have a dependent, the service is a dependent role in SIM hosted service, and it goes to a system, and the system happens to be the server system. It also is a dependent role in a service-to-service dependency, and here we see it's dependent on the Webm server itself. So the Webm server is a service, and the protocol service is dependent on it. And lastly, we have service access by SAP. So the service is the antecedent. You follow this service access by SAP, and you get to a TCP protocol endpoint. So that leads to the question, what do we have with the TCP protocol endpoint? And for that, we'll issue an instance enumerate on TCP protocol endpoint. And we'll ask for a property list of name, instance ID, name format, operational status, and protocol IF type. And we see the TCP 11 with an instance ID, a name format of port address, protocol, and number. Operational status is okay, and the protocol IF type is 4111, which indicates TCP IP or TCP. Now, this protocol endpoint is basically the address when you're talking to the Webm server. So that covers everything you're going to find, or almost everything you're going to find in the interop namespace. So hopefully you get a feeling for what's in the interop namespace and what it manages.